In this chapter, so we're in chapter 13, and this will be another chapter on probability. We're kind of getting into a little bit more general rules, I guess. Um, Whereas in the last chapter, we kind of looked at very specific examples where things were either disjoint or independent. What if things are not disjoint? How do we handle that? So that's kind of what we're going to be talking about here. So for this first example, suppose you have each denomination of dollar bills in your wallet. So S is the sample space. So S would be 1, 2, 5, 10, 20, 50, 100. We're going to let set A be the odd numbered values. So that would be 1 and 5. And then set B is going to be the bills of the building. So that would be 5, 10, 20, 50, and 100. So Y is probability of A or B. Now remember, or means add. We talked about that in the last video. Y is the probability of A or B not equal to a probability of A plus probability B. And the reason is A and B are not disjoint. So we said last time that that only works if the two things are disjoint. So they're not disjoint. And how do we know they're not disjoint? The $5 is in both. So remember, disjoint events cannot happen at the same time, or to put it another way, there are no common elements between them. So in this case, $5 is in A, it's an odd numbered value, and $5 is in B, it's a bill with a building on the back. So what do we do if two events are not disjoint? How can we find the probability of A or B if A and B are not disjoint? So this general addition rule will work whether they are disjoint or not. So to illustrate this, we're going to be drawing Venn diagrams in this chapter. So let's look at a Venn diagram. And let's say that we have circle A here, we have circle B here, and we want to find the probability of A or B. And so again, these are not disjoint because we have overlap. If they were disjoint, it would be two separate circles with no overlap. So these are not disjoint. And so if we did what we did in the last chapter, so or means add, so we'll say the probability of A plus probability of B. Now, what happens? So we did A, so that would be covering all of the A circle. We did all of B, that would be covering all of the B circle. All right, now what have we done wrong? Well, we have counted all of the overlap twice. So we counted it when we added the A circle, we counted it when we added the B circle. So we've counted the A and B, that's what the middle would be. We have counted that twice. And so now the rule with probability is only count everything. If you want to count something, you only count it once. You cannot count it twice. So what we need to do, because we counted it twice, we're going to subtract the A and B. And if you count it twice, you subtract it once. Now you've only counted it once. So this works whether A and B are disjoint or not. So this could be for any A and B. So it doesn't matter if they're disjoint, not disjoint, it doesn't matter. If they are disjoint, then the probability of A and B is 0, and then we just end up with this part that we had in the last chapter. So either way, this will work. So let's look at an example. Probability, let's see, 33% of high school students from a particular survey were involved in a relationship, 25% were involved in sports, 11% answered yes to both. Find the probability that a randomly selected student is in a relationship or involved in sports. So we'll just use this formula. So we have the probability of R or S, relationship or sports, is the probability of relationship plus probability of sports minus probability of both. So we can just use this very simple formula and very easy to do. So probability of relationship would be the 0.33. Probability of sports would be the 0.25, and then minus probability of both, which is 0.11, and then we get 0.47 for the total there. Okay, so very easy. This is a formula you'll need to have memorized, and I usually, so a lot of times I don't really say memorize formulas a lot. And I don't know that you should memorize this one, but it's more important if you can kind of draw this Venn diagram and figure out what the formula is. That's much better than memorizing it. So I recommend doing that. The other thing that's helpful for remembering formulas is every time that you use a formula, write the formula down. So we kind of did that here. We didn't use the A and the B, but it's still the same. But write the formula down before you plug anything in, and that will help you to remember the formula. And then the other thing, of course, if you can derive the formula yourself, then you don't have to memorize it. All right, so let's look at another example. And actually, we're going to continue with this. So same situation. And so we have three different questions here. We're gonna draw a Venn diagram and use the Venn diagram for all three. Now, if you can draw a Venn diagram in this way, none of these questions are very hard. So if you don't use the Venn diagram, it's kind of difficult, not in a relationship, not in sports versus in a relationship. So these seem very probably, how would you even go about this? Just looking at that. But if you draw the Venn diagram, then it's very simple. So let's just write what we were given on the previous page, just so we have it here. So the probability of relationship was 33, sports was 25, and then probability of both is 11. All right, so what we're going to do whenever you are labeling Venn diagrams, and we're only going to have Venn diagrams with two circles, so it's not going to get too complex. But even if it did, the principle still remains. You still kind of do it the same way. So start in the middle. So what is the probability you're in the middle? That's the probability of both. So that would just be 11. And I'm going to write 11 instead of 0.11 just to save space. Okay, so now work your way out. So how would you describe this part of the R circle? That would be people who are in a relationship only. So these people would be in a relationship but not playing sports. So the R circle is 33%, the total R circle. We have 11 of the 33 right here. So the rest of the 33 must be over here. So that would be 22. So these two things have to add up to 33. We know this one is 11. That leaves 22 for this one. And then same thing for this. We know this is 11. The entire S circle has to be 25. So that leaves 14 there. So 14 plus 11 has to equal to 25. 11 plus 22 has to equal to 33. All right, and then all that's left is the part outside of the circle. And the way you can get that is just do 100 minus the parts that we've gotten so far. So we do that and we get 0.53. So now the whole thing is labeled and we should be able to answer any of these three questions pretty easily. Not in a relationship and not in sports. So that would be the part outside the circles. So that would just be the 0.53. In a relationship, but no sports. Now, but, is that an and or an or? So the but is an and. So in a relationship and no sports, that would be this part over here. So that would be the 0.22. Now, one thing I didn't say that we need to make sure we clarify, whenever you see or, so the or that we saw in the last problem, or always includes both. The only time it does not include both is if it's like this, where it explicitly says, but not both. So obviously we're not going to include both there. But or includes both. Let's write it here. Or includes both unless stated otherwise. And I know in everyday language, if you say or, typically you don't mean both, but in math you do. So in ordinary language, if you say, I'm going to go to Chick-fil-A or I'm going to go to McDonald's for lunch, obviously you're probably not going to go to both. At least you're not going to eat at both. So in everyday language, or does not include both, but in math, or does include both, unless, like this one, it's explicitly stating that it's not including both. So this one, in a relationship or in sports, but not both, that would be the part in the circles, but not in both. So this would be the 0.22 plus the 0.14. That would be the 0.36. All right. So again, when you draw the Venn diagram, start from the middle, work your way out, and then any of these questions that we could ask, there are more that you could ask probably. They're pretty easy. So if you get the Venn diagram labeled correctly, then those are usually pretty easy. So let's see another example. This is basically doing the same thing. 71% use Facebook, 18% Twitter, 15% do both. And then we'll find these various probabilities. So one thing I talked about in chapter 12 is how do you know when to do what? So some of the things we did in the last chapter, you'd survey 3 people and see what's the probability they all pick purple for the M&M or whatever it was. So in that one, we drew kind of three lines for the 3 people that we were going to pick. What do you want to happen this one? What do you want to happen here? What do you want to happen here? So we don't do that here. And how would you know that? Just kind of reading the problem. So there is a way. Those are independent events that we talked about in chapter 12, or they were disjoint events where it is either this or is this. Here, if you ever have a problem that gives you the probability of one thing and the probability of another thing and the probability of both, then you draw a Venn diagram. And I guarantee every time that you have a situation like that, you can draw a Venn diagram. You may not necessarily need to, like in the relationship or sports, we didn't need to draw the Venn diagram, but you can. And if you can remember that, so that's kind of like I talked about in chapter 12, that's kind of the tricky part to all of these is when do you do which method for solving these problems. And that's when you draw a Venn diagram, have the probability of 2 different things, and then you have the probability of both. In chapter 12, you might have the probability of 3 things. You're not going to have the probability of both or all 3 or anything like that. So the both especially is kind of the Venn diagram indicator. So let's draw a Venn diagram for this one, and then we can answer the questions. So 2 circles, we know they overlap because we have the probability of both. So we have Facebook, we have Twitter. Start in the middle, work your way out. So we have 15 for the middle, so 15% do both. What would be the percent that only do Facebook? So that would be 71 that do Facebook minus 15 that do both. So that leaves 56 that are only on Facebook. And then 18% are on Twitter. That's 18% for this circle. 18 minus 15 gives us 3 for the part that only use Twitter. And then to get the part outside the circles, we just do 100 minus the 3 numbers that we have in our board here. 56 minus 15 minus 3, and that gives us 26. All right, so 26 will go out here. All right, so now let's see, Facebook or Twitter. So probability of Facebook or Twitter. So we can use the formula, Facebook plus probability of Twitter minus probability of both. And so we have 0.7, so we're not really using the Venn diagram for this, 0.71, but I'll show you how you can use the Venn diagram. Plus 0.18 minus 0.15, and let's see, that would be 3, so that's 0.74. Now, there's another way you can do this, and that is to use the Venn diagram. So probability of Facebook or Twitter, you can just add these 3. So we're looking, Facebook or Twitter would be anything that's in either of the circles. So 56 plus 15.15 plus 0.03. And that gives us 0.74 again. So either way, either of those ways is fine. You might also notice that if you do 100 minus 26, that gives us 74. And that's because we're basically counting everything except the people that are not in either circle. So either of those ways, any of those ways would be fine. All right, Facebook or Twitter, but not both. So that would just be the 56 plus the 3. So again, that's not counting the middle, or does count the middle unless it says otherwise. And then last one doesn't use either Facebook or Twitter. That's just the 0.26. So hopefully you can see, if you can draw the Venn diagram, you can do these really quickly. Like it really doesn't take much time at all. And drawing the Venn diagram, if you do it a few times, gets pretty, you can do those pretty quickly too, once you get used to it. So make sure you practice these and email me if you have any questions. I know probably go a little bit faster these videos, but you can rewatch, and you can also email if you have any questions.